Hello and a very good afternoon to all of you. I am Sakshi and it's my pleasure to welcome you all on behalf of eMobility Plus and First View Group. Thank you for joining us today for our webinar on the role of additive manufacturing, 3D printing in transforming of electric automobiles. EVs are reshaping transportation, but simultaneously, they also demand an entirely distinct vehicle production journey. In the next 1.5 hours, we'll explore how additive manufacturing with industrial 3D printing technology has emerged as one of the most powerful tools which can make this journey easy, less costly, and will also increase the growth of the industry exponentially. Here's a quick brief about today's program. We'll begin the webinar with a very interesting presentation, which will be followed by a panel discussion and concluded by a question and answer session. Before initiating the proceedings for the day, we would like to thank our partner, Design Tech Systems Private Limited, for their immense support in planning and executing this webinar. Now, without any further ado, it's time to start the webinar with the presentation by Mr. Ganesh Babu, who's the technical head of Design Tech Systems Private Limited. Over to you, sir. Welcome to screen.
Well, a very warm welcome to all of you. Good afternoon, ladies and gentlemen. So, I have today been given the opportunity to present to you on the role of additive manufacturing or 3D printing in transforming manufacturing of electric vehicles. Well, I speak to you right now from the city of Coimbatore, wherein I am having a business travel. Soon after completing today's presentation, I'm heading to another platform wherein I have to have a live presentation going on regarding castings and manufacturings using additive manufacturing. Well, I'm based out of Bangalore. I come from a background of design manufacturing with 3 decades. I had a role to play with Stratasys as an application specialist for 5 plus years. Well, we also have all the experienced panelists and speakers along with me. I welcome all of you all. And on behalf of Design Tech, today I have the privilege to present to you on our corporate profile very briefly. We are the VARs for various CAD CAM, CAE, and PLM solutions apart from additive manufacturing technologies, primarily from Stratasys. We are the platinum partners of Stratasys. We also have the engineering services domain. Apart from that, we are into augmented reality and mixed reality experiences. Well, these are some of the OEMs that we are associated with. Well, primarily on the top third row, you see Stratasys Design Tech. So today's presentation is going to be completely on the Stratasys product line for automobile manufacturing as well as associating for e-mobility. Well, so we are an organization widely spread across the country, presence in 9 cities in India, as well as we have overseas offices as well. We are into 25th year of operations. Well, with this short brief on design tech, since I have a very short presentation time, I would like to lead on to the agenda today to take you all through with additive manufacturing introduction, Stratasys AM technologies for automotive applications exclusively, prototyping to tooling and manufacturing. Primarily, we are going to talk about print to perform applications, automotive case studies, and then we'll get into the panelist discussion. Now, additive versus subtractive manufacturing, there shouldn't be any further introduction on additive technologies today. Reason, it is very well known that the process of additive manufacturing is opposite to the subtractive techniques. And while we are looking at e-mobility, all the while we have been looking at the automotives or for transportation means, we have been using fuel based automotives primarily, or gasoline based automotives. But today, the transformation to electric vehicles is catching up for having a greener and more viable world to live upon. So, very soon, we are going to see that there are going to be fuel variants getting predominantly extinct rather from existence. However, in this journey, in this onward journey of transformation to the electric vehicle mobility, there is not going to be much of a change when it comes to the overall structure of an automotive. But the driving mechanism, the force which drives the mechanism within the automotive, and the components that constitute the electric vehicle is going to be very minimal in terms of manufacturing. However, while we are going to look at lightweighting as well as creating electric vehicles, the structure and the design philosophies of automotive designs are not going to be far from changing, but it's still going to become more and more creative. So, in this journey, today we are going to look at electric vehicles which are predominantly having a powertrain that comprises a battery pack, an electric motor, and transmission that happens for the momentum created on the electric automotives. But for the fuel automotives, an internal combustion mechanism of the engine that burns the fuel to propel and gain momentum for the vehicle is what predominantly separates both of them. But ideally, an electric car is always called as a silent machine, thanks to the electric motor which takes care of it. But whereas in a layman's language, while we are looking at a fuel based engine, it burns fuel to generate energy to propel the vehicle, as simple as such. So, moving on, while we talk about the key challenges in the automotive vertical, there are increasing regulatory requirements on the existing fuel based variants, tighter fuel economy and emission requirements, and more importantly, when we are looking at more and more upgrades and newer designs in the fuel variants that are coming up, the prices are also increasing, and more importantly, the preference for customization, low volume, and high level of complexity comes into taking over the latest designs in the automotive world. But now, while we look at some of the challenges, what is that which is so very interesting while we are looking at additive manufacturing as a technology for supporting automotive verticals? Well, rapid prototyping, as we all know, from concept to physical realization of parts, we get into the mode of rapid prototyping. Additive manufacturing has been predominantly understood for creating a physical model, which are called as a rapid prototype. However, over the years, the evolution of the technology and primarily strategies have been the game changers to revolutionize the way in which how 3D printing has been looked upon. So now we are going to look at production parts. Production parts that have been rolled out from 3D printers are today assigned upon end use automotives that work predominantly till the end of life. So there are quite a lot of questions when it comes to production parts. What about the surface qualities? What about the limitations in terms of materials and so on? As I mentioned, Stratasys has been a game changer. We will gather more information in the coming slides on the Stratasys front. But now, the next segment that I'm focused on is the forming tools. Well, while we talk about forming tools, tools that have been manufactured through the subtractive manufacturing methods that support productionizing of components. So, a metal predominantly being used. Here we are talking about Stratus technologies with polymer based tools that give shape to metal. And while we talk about manufacturing aids, it's quite a lot. Cost effectively printing without having to compress, without having to limit the performance of a given tool on the shop floor is something which is very interesting to take note. While we talk about manufacturing aids, lightweighting of tools using polymers, but without having to compromise on the functionality of the tools, today designers, manufacturers at all industry verticals are having the privilege to work with Stratasys product lines to take it to the next level of manufacturing. Well, with this brief introduction on the additive manufacturing for the automotive segment, let's look at Stratasys, the world leaders in additive manufacturing technologies, innovation for the digital factory. While we talk about Stratasys, the 3D printing solutions company, it has touched upon every given vertical, whether it is the space stations that operate rockets that are flying with 3D printed hardware, the medical world that could print human anatomies very close to what they could mimic, the 3D printed anatomies that could mimic what nature has given us very, very closely. It's an exciting world while we look into Stratasys on the various solutions that they provide. Apart from the aerospace, automotive, the medical segment has been fascinated to work with some of the world leading technologies where it has been untouched by competition with multi material processing of human anatomies. For the last 3+ decades, headquartered in the US, Eden Prairie, and Rehovot of Israel, there have been multiple granted as well as pending patents for Stratasys. As a publicly traded company on Nasdaq, Stratasys have never looked beyond any challenges that comes their way. They have been able to add mainstream technologies apart from what they have developed. But before getting into more on the core strength of Stratasys technologies, let me also give you a brief overview in terms of traditional or subtractive manufacturing processes. There are quite a lot of advantages. It's a good fit for high volume productivity, irrespective of whatever the components are, whether it is a polymer based or a metal based outcome that you are expecting from a manufactured tool. The subtractive process enables you to process your outcomes or the parts with a wide variety of materials. That's too very interesting to take note. Newer materials get developed, they get processed with the subtractive manufactured production tools. But the advantages are huge investments and the time spent in getting the manufactured tools are too very long. Ideally, that's a challenge where additive manufacturing scores over in the process of providing more quicker and primarily a cost effective solution. Advantages, you're not going to be limited for any design barriers in manufacturing because additive as a process gives you an unlimited variation of complexity in designs which you could adapt and start printing. You can integrate your components. We call them as part consolidation. You can have combination of hybrid outcomes with plastics as well as metals integrated in the process of manufacturing. You have a flexible supply chain, which is very, very important today. No need to have physical tooling or storage spaces that occupy a large factory floor space. But the disadvantages are limited materials, very limited materials. And that's where the R&D of Stratasys comes into picture to integrate and start working for customer based, end use application based materials that have been rolled out. So traditionally, we look at manufacturing as a more mature technology ideally. But whereas the various advantages that today Stratasys offers gives us the design freedom, design context. So ideally, you can have part consolidation, multifunctionality parts, and then any optimized structures. It could be lattice structures or design for additive manufacturing is also a great boon that creates lightweight parts, and more importantly, it also ensures that the process of 3D printing is much faster, consuming lesser materials, etc. Well, What the customers gain by using additive manufacturing has been summarized over here. Low volume custom applications can be addressed, on demand productions that could be made fast. And while we are looking at on demand short run productions, ideally today 3D printing stands up to meet those needs of manufacturing quantities. Part assembly consolidation, yes. Here we are talking about limiting the part count for manufacturing, adding multiple parts together and consolidating the design, making it more complex is ideally a sweet spot for additive manufacturing. And while we are looking at supporting lean initiatives or true and just in time manufacturing, it is the best today to go along with additive technologies. While we talk about additive technologies, here we are looking at Stratasys as an industry in motion, moving beyond the general platforms, focusing more on the deep applications. What are these specialty applications that we're going to look at? And what are the technologies that Stratasys today supports? So today we are looking at five different technologies, best in class technologies, world renowned technologies today, which have been predominantly supported by Stratasys. All the while, it has been the industrial FDM and the polyjet technologies which were ruling the product lines of Stratasys. But with the introduction of few more additional technologies, wherein companies have been acquired by Stratasys and they have reinvented the wheel of manufacturing. Today, we are looking at manufacturing tools and production parts from these technologies. So, ideally, we are going to look into very briefly on all these five technologies and where it's going to lead for the automotive world to acquire the best in class parts for manufacturing. So, well, on the left is Polyjet, which is a multi material technology that could combine seven different materials on the fly. You have 500,000 different digital properties that you can acquire, 1900 plus different Pantone shades with which you'll be able to realize and correlate the colors that are required in a given product. You could texture map, you could have high fidelity models rolled out from the Polyjet systems. Every text and label in colors as end product can be realized. Well, post printing with very minimal post processing, you could achieve the realisms of the designer's creativity. Stereolithography is again a best in class single material SLA process, and it is proven for producing wonderful parts precisely, high precision, high surface quality, and so on and so forth. Origin P3 is a programmable technology. Here we are looking at DLP, digital light processing, as the technique. But what does the Origin P3 do when in comparison to other P3 technologies, other DLP technologies, is that today you have an open source platform, and ideally there are world class materials that are available from the best of the polymer manufacturers like BASF, Loctite, Enkel, Covestro, Avionics, etc. And here is a technology that could meet hundreds and thousands of part manufacturing that could happen with the Origin P3 platform. Highly accurate, injection molded surface quality, and much more to talk about. Saf is a high volume production powder bed fusion technology, highly intricate, high strength polyamide parts that could be rolled out, but very unique, not in comparison to the traditional SLS process that the world knows. There is a huge value add in terms of all these product lines that have been rolled out. Industrial FDM has been a proven technology. It has been a patented technology invented by Stratasys. After the patent expiry, there have been extrusion machines that have been rolled out and called as FDM, but unlikely they are not FDM. They are fused filament fabrication systems. But when it comes to repeatability, reliability, high strength, highly accurate outcomes, the FDM, industrial FDM from Stratasys still stands good for all manufacturing, and any given verticals can expect highly durable parts with highest accuracies of throughput. Moving on very quickly, here we have a brief on the Saf technology. We call it as selective absorption fusion, wherein while having to support the green revolution for automobile manufacturing, here is a technology where it is a 100% bio-based, sustainable castor oil-based raw material, polyamide, PA11. And there are various value adds working with this material and the technology. And the DLP process of the Origin one, it's a VAT-based system, ideally. best fit when it comes to realizing end production parts. I'll take you through with a few other throughputs, but the summarization on the DLP stands for high throughput, range of high performance material, injection molded quality. And here we are looking at Polyjet. As I mentioned, here's a platform that could allow you to mix and match seven different materials on the go. The eighth material can be the support material, soluble in nature, as well as a washable material, which are available. Highly front ending to support design realisms for high fidelity modeling. CMF outputs, color, material, finish are today never left behind. In a single shot printing, you'll be able to achieve that. And with the polyjet, the realization of lighting blocks to get closer to what the injection molded quality is in your product development. If you're going to look at making these clear light blocks, truly the best in class the world could see is the polyjet technology from Stratasys. So polyjet parts are used for lighting assessments because of the transparency and the compatibility to reach to the colors that the production parts are looked upon can be equated with the polyjet system. Now looking at the FDM technology, these are workhorses. Never looking back. You could customize your prints, solid to the various levels of customized throughputs that could be realized with the technology. The applications vary from prototyping to tooling and end user parts with the Stratasys product line. But the key applications that we look at using all these technologies are whether it is large prototyping, jigs and fixtures that could support the manufacturing lines on the shop floor, tooling applications, soluble cores, wherein without any split for non-linear old features, you will have the soluble cores that could support you to realize your parts in quick turnaround time without any tooling. But when it comes to end use applications, here we are having for the automotives exclusively that you can print with a UV stable material called as ASA that allows you to work with material, and you could have your class of designs that you can print and mount them on these bumpers, which are directly called as end use car panel applications that are well supported. And when it comes to the exteriors of the automotive, irrespective of what the mode of fuel or whether it's going to be gasoline or electric vehicles, there's no compromise. Any new designs here can be printed out with five sections using the polycarbonate material by the FDM technology. Here you could see a bumper which has been mounted directly post printing. After printing, you bond the parts together and mount them on the vehicle to check on the feasibility of the new design getting mounted. And you could even try for field tests by running the automotive to check on various aspects of its functionality. Very similarly, here we also see a full car body. Now, this is exactly where it goes. While we are talking about electric mobility, irrespective of any given variant for the automotive sector, what is very interesting is how soon, how quickly you can have high strength, highly durable outputs. Not only automotives, I have been associated with various aerospace majors to create fuselages, wherein whether it's an helicopter model or an aerospace design, the FDM technology, the F900, stands by to print large parts, segmented large parts that can be mounted together post printing. And now comes the interesting aspect of applications. Every given product line has something or the other to talk about in terms of sheet metal components. Now, while we look at sheet metal parts, giving shape to sheet metal parts without the progressive tooling, we have to look into form tools, stage-wise forming tools. Here we have materials, ABS, that could actually take compressive loads of around 3,000 pounds, polycarbonate around 7,000 plus, Ultem 9085 grade can touch upon 10,000 pounds of compressive loads on a 1 cubic inch of block. And when you use Ultem 1010, you can exceed beyond 12,000 pounds. Ideally, a best fit when it comes for sheet metal forming. Typically, you are not limited with only soft metal. Yes, you can work with titanium, you can work with stainless steel, but the quantities can get narrowed down well before your production tooling can come into the picture. These could give you a batch quantity manufacturing that could happen on the fly. Overnight printing of tools, you have your blanks ready and put them on these polymer tools and get to realize those quick numbers in a very short period of time. Today, there are materials which are carbon fiber filled nylon that could be used for more durable printing. Here, they are looking at even if it is not 95% on the lead time savings or on the cost savings, but it can be predominantly touching irrespective of whatever it could be. There could be in all in the excess of close to 60 and above the percentage of savings in terms of both cost as well as time by using the polymer based FDM technology in printing form tools for sheet metal forming applications. The variety of materials, the high performance range of materials that the FDM technology offers today can give you materials such as the nylon 12 CF, the FDM nylon 12 CF. These are chopped carbon fibers wherein these materials withstand high fatigue resistance as well as when it comes to high strength and stiffness to weight ratio, an excellent material for lightweighting tooling, functional prototyping, production parts, end use parts, and more so. Very similarly, we have the Antero 800 Na. Antero is a grade for equating the peak material, the PEC material rather. We call them as polyether ketone based material. Well, it is a high chemical resistance material and an high temperature resistant material with very low ultra low outgassing and high resistant properties wherein they can withstand more and more manufacturing rigors on the shop floor to support the shop floor manufacturing. While we deep dive into automotive jigs and fixtures, the complexities of a given part that get machined, irrespective of wherever we are, whichever sector of manufacturing it is. Here is some of the automotive gauges that have been printed. All the while it has been metal. You need to suspend those metal kengos for checking, edge checking through cranes, etc. Today you have the flexibility to design, adapting to design for additive manufacturing, your lightweighting, and more importantly, a single operator can use a 3D printed ABS material output for edge checking gauges that are getting manufactured. And on the same lines, you have got various automotive majors who are using for end use applications and end of arm applications such as the nylon 12 CF tooling, wherein it is a single part irrespective of while we are looking at part consolidation to the traditional methods as you see the metal blocks, they are huge heavy, multiple settings are called for the manufacturing of these complex manufacturing tools. But today with 3D printing as a single step solution, you're able to realize end use parts that could go on automotives. Some of the case studies, very quickly, I'll rush them through. Minimizer uses these fenders. These are fenders on the truck, which are being printed with black Ultim material directly mounted onto the truck and field tested for the design, for the part strength, for the design that matters for them before stepping into productivity. They use for low quantity manufacturing, it's an ideal fit. And on the transmission gears, etc., premium transmission in India uses ABS based outputs for complex transmission parts that are getting manufactured. And when we are looking at tools for the manufacturing of product lines, automotive product lines, here we have BMW using Stratasys FDM technology for every vehicle variant. Nearly more than 400 plus jigs and fixtures have been rolled out under the hood, as well as while you're looking at headlight alignment or emblem placement, fixture, cubing device, and so on and so forth. All these are quickly manufactured. There you see on the left the narrowed handles, heavy metal fixtures being replaced with lightweight internal sparse mode of printing, ideally giving more comfort, addressing worker fatigues in the automotive sector. Automotives have started using them on the shop floor. Multiple sets of these printed parts are today used on the shop floor. There you get to see the various designs wherein additive has taken over and supported the manufacturing lines in a very big way. Hyundai has used this instrument panel. What is interesting to talk about the instrument panel as a prototype part is printed in multiple segments and then bonded together. The creative edge over here for the designer is not just catching flaws on the design, but beyond that, when the production has to start, we call as concurrent engineering to develop fixtures, all those blue stubs, 7 small blue stubs with the complex profiles that have been captured from the part are printed with the FDM ABS, blue material. And they are one time set up on the CNC platform, I would rather take a printed part, equate it, and start checking for work holding as well as for CMM inspection. And this is the creative edge. While we're looking at small little stubs that they are taking the entire instrument panel load, gives a creative thought. And that has led for various new and more interesting shop floor application fixtures. Here is the smart manufactured fixtures which I have been associated for a SUV 500. This takes up a load of close to 280 kgs for setting the carriage and the engine to be put up for assembly. And ideally, when it comes to low volume production, here we are looking at a technology that could support with nylon 12, nylon 6, nylon 12 CF, and so on. So the FDM is for high strength durability that supports all the automotive manufacturing as well as manufacturing tools. Now, Origin 1, the P3 technology, again, when we are getting to master market as fast as possible 3D printed end use parts, here we are looking at finally realizing flexibility. While we are talking about moving on to the EV manufacturing, what is interesting is, are we prepared to have quicker solutions to support the cost of newer development that gets happened in the design and the manufacturing process? Yes, here it is time for end use part manufacturing. Ideally, the best fit here is for all small components, whether it is the connectors, all of them with very minimal time that gets consumed, with precisely high precision and injection molded quality, higher surface roughness. Here we'll be able to achieve, as an open source platform, it can also let you achieve very fine accuracies, tough and robust materials that are available. And when the surface quality is of injection molded grade, there is unlimited possibilities to adapt to newer modes of automotive manufacturing of end use parts. Ideally, the best fit here is a single system that can give you high strength materials, flexible materials, all on a single platform. And more importantly, with very quick and ease of change of materials from one material to the other, the more complex in nature, even the softer tool manufacturing is eliminated. And we have FST grade of materials that also support for stringent manufacturing requirements and flexible rubber seals for the automotive. All this could be manufactured with the Origin P3 technology. And moving on with the additive manufacturing produced tools, here is something more of an hybrid case, wherein the complexity of the surface, which has a complex 5-axis surface that needs a fixture for drilling with a certain pitch and distance and accuracies. You have fixtures that have been generated with 3D printing using FDM technology. So tooling that have more complexity are well addressed, improved ergonomics, you lightweight them, weight reduction, easy customization, and today these are cost effective for low quantities and a best fit to begin with. So elevating capability to advance a digital factory has always been the mantra for Stratasys. Stratasys have their rights choice of materials to select repetitive quality, and more importantly, without having to think in terms about not to work along with the subtractive techniques, additive can never support production. So hence it is known as a factory integrated technology which supports and can be used on the shop floor along with the traditional and subtractive techniques to support and work with. Well, I have come to the end of my presentation. Thank you very much.
Thank you so much, sir, for this insightful presentation and for setting the tone of the webinar. Sir, if you could just stop sharing your screen.
Well, yes, I have stopped presenting my screen.
Yes, sir. Thank you so much, sir. Now it's time to begin with our much awaited panel discussion. And to discuss this, we have on the panel with us Mr. Rahul Shonak from Gensol Engineering, Mr. Lalit Ahuja from Varrock Engineering, Mr. Ganesh Babu from Design Tech Systems, Mr. Satish Kumar from StratSys India, Mr. Pritesh Doshi from Dana Incorporation, Mr. Subhabrata Ghosh from Batrix, who will also be moderating the session. I welcome all our panelists on the screen and request Mr. Ghosh to lead the discussion. Before that, I would also like to make a small announcement here, requesting all the attendees to post their questions in the Q&A box. Our panelists will take those questions after the session. Over to you, Mr. Ghosh.
Yeah, hi, good afternoon, team. I hope I'm quite audible.
Yes, sir.
So great. So thanks, Mr. Mahesh Babu, for the wonderful presentation. And I think welcome to the world of disruption, especially in India, how it is happening. We are in Batrix. Just 1.5 years back, we are making around 5 batteries a day, and currently we are making around 500 batteries a day. And just this month, we are crossing around 1,000 batteries a day. So, that's EV. So I'll come to straight away on the EV segment. So starting from 1%, if you talk about the two-wheeler, starting from 1% now, it has last year it has crossed around 3% of the total two-wheeler segment converted to EV. This year expected around 6 to 8% will be converted to EV. So around 8 to 10 lakhs two-wheeler going to manufacturers. Even in four-wheeler market, very exciting to look at the market right now, where we can see like electric cars like Nexon EV is in waiting list. So it's very interesting in India right now. And with this change, I think there's come a lot of challenges, especially related to homologation, especially related to product change, whether it is BS5 to BS6, or this new AIS amendment on lithium battery, or FAME subsidy related to the changes in the product. So whether it is ICE or EV, there are a lot of changes happening on the product because of these government initiatives and the customer expectations. So the market is changing very fast. I think the prototyping are, just 1 year back, the number of product we were making in Batrix, I think similar kind of numbers of protos now we are making in Batrix. So the prototyping and change required very fast, conversion of the tools, which previously used to take around 3 4 months for the tooling and then trials, and it used to take us 6 months and 8 months. Where the customer expectation right now, within a month or two, they need to deliver. Like if you talk about the new AIS amendment, they're asking for it within 1 month, changing the entire lithium battery design concept. So I think Mr. Ganesh Babu can help us a lot in this. So I'll start with Mr. Rahul Shonak, who's the CEO for Gensel Engineering, the challenges in this changing environment, and what kind of support he can get on additive manufacturing.
Thanks, Mr. Subrata, and thanks, Mr. Ganesh, for running us through with the technology, changing technology, which is helping the we as automotive engineers at Gensol. We are coming up with an electric car, the entry level electric car, which India market will see in the next year quarter 1. Here, if I go back in time, I think we had the similar journey which Mr. Ghosh, you have said that while developing the batteries, you were into prototypes, and yes, we were into prototypes when back in 2018 we cleared the homologation of our car, and to make the proof of concept, we actually aggressively used the additive manufacturing process. This was primarily to have the solution on the table, to put the car into ARAI and see how things are moving. Assembling a car, it's like keeping together 1,000 parts and moving it together. And additive manufacturing has actually helped us in making it bit faster. Traditionally, if I see 10 years 20 years back, when any program of automotive engineering used to take shape, it used to take approximately 4 or 5 years to go from scratch to come to the SOP, start of production stage. Right now this has been reduced a lot, and this has actually helped by adopting these technology. And now the good part is we're not talking about proof of concept anymore. We are talking about making the serial production parts in additive manufacturing. Yes, there are some on ground challenges. Yes, the costs are a bit higher while we adopt, but I'm sure platform and machineries like Stratasys and a couple of other companies are actually making it possible that apart from proof of concept, additive manufacturing can be helpful in serial production. Looking at the this is on the manufacturer side of the story. There is another side of the story where is the consumer side. Now, how consumers are getting benefited of this technology? Not directly, maybe. If I look at the perspective, uh, in hindsight, consumer get the product faster from the manufacturers. In a way, it's helping. We go to any showroom, we go any online platform. The cars are in waiting in not now. OEMs are not talking about months; they are talking about years of waiting. So consumers are actually waiting for all the vehicles to come on the road, which they have booked, even after paying hefty amount of booking money. So these technology have a good amount of higher adoption when it comes to consumers. So it's win-win for manufacturers. It's beneficial for consumers. It's beneficial, and there is another aspect. When we take the traditional manufacturing operations, the quality or I can say the accuracy of the part is not that great. But when it comes to highly automated additive manufacturing, this helps keep the part in check, and you get the accurate part, and uh, the probability of failing it into the market is bit less. So I see benefit all across the table. I think with this I can say that we are very much in for it when it comes to vehicle development, when it comes to part development, and it's having a lot of benefit while using. I'm not sure. Your voice is not coming clear, Mr. Ghosh. If you're
No, sir, you're not audible.
Yeah, I hope it is audible now.
Yes, sir.
Absolutely. Yeah.
Oh, great. So thanks, Mr. Rahul, for the wonderful discussion. Over to you, Mr. Lalit. I think lighting is one of the major requirement in case of especially homologation.
Yeah.
So over to Mr. Lalit. How, like, what are the challenges in the prototyping, tooling, and how this additive 3D printing can help us to solve that issues?
Okay. Of course, there is a challenge, of course, for the lighting specifically. Okay, and but thanks to Stratasys, in fact, along with Satish, we worked hard on those to meet, and based on that, even we decided to move ahead for this in-house capability of prototyping. We were earlier making the prototyping from out of India because though there was a challenge to get the finish what we are looking uh, in the product, especially from that performance point of view, because a lot of skill set is required. Even in this case, I'm not saying is we are at par, but of course I think so. We is not a matter of time. Maybe in another year, so we are able to get that specialization in that particular additive manufacturing and the material as well, because tasks are already given to strategist team what exactly we are looking from that lighting perspective. Is a really good tool, but the thing is how to use that is more important from the lighting perspective. So they have a very good option in the adaptive. Now we can make, earlier we were making soft tools to get that performance in prior to go for the tool cutting. That soft tool cost a lot, but with this technology we start working at our in-house facility, and now I think we are just started. I'm not saying is at par, but we are confident. Yes, with the help of that, we are able to reduce the cost, time. Okay, especially for the designers where the complex designs are there in the optics side, is a big challenge from the polishing side because it's very important to get that optics facet in such a way and not be disturbed. And the accuracy, what we were looking, we have taken a trial and we found that accuracy is at par what we were. Okay. Uh, so I think this technology is really, really helpful for that. And if I'm not wrong, in India, we are the one who introduced or adopted this technology. Okay, very first. And as a Varrock, we always try to set a benchmark as a first innovator to introduce something new. Okay, so with that, we are nowadays, in fact, the upcoming auto show, you will see the many protos we are going to be built through this technology and showcase. Thank you.
I just have a counter question on this. Like, what's your experience on the prototyping, considering the strength? Even is there any chances that okay, maybe with previously you used to test maybe hundred of parameters with
Yeah.
existing proto system, but with 3D printing, additive 3D printing, you can out of 100 maybe 80 you can test, 20 you cannot test because of many reasons. Is there any point related to this?
Yeah. It was a very well question. In fact, this was the challenge for in front of us as well while adopting and going forward. And we always say it's not possible to do a test on these protos because earlier the people were working SLA, SLS, and these were very fragile parts. And it's only for fit and function we were verifying for the same, and we were never ever conducted any test. And for those testing, we were dependent on that soft molds like silicone based soft molds or aluminum based soft molds. But recently, we achieved that testing on that parts which is made by that polyjet machine. Okay, and whatever the testings uh, whatever the testing is required on the product validation, we perform all tests. Okay, even the vehicle level test as well, and successfully we achieved that. Of course, there was little challenges were there because it was new to us, even new to the team of statistics, because what exactly we were expecting from that test site. Okay, but after joint efforts, so we are able to meet that requirement. And nowadays, like, we are not dependent on the soft tool now more. So whatever the product or the new programs are running, we are making protos through that adaptive manufacturing that is specifically for polyjet. Okay, which is really, really very good material in terms of strength, in terms of finish, in terms of transparency. What we are looking, of course, not at par, but for the test point of view, yes, it is there where we can say confidently, yes, what we are designing will be meet that functional requirement, what customer expectation is. Yeah.
Thank you. Over to you, Mr. Satish Kumar. What's your experience on the prototyping and how this can help your area?
Okay, so good afternoon, everyone. First of all, it is very good see the kind of this kind of a panel happening in India, especially focusing on EV, because right now this is becoming one of the major trend. Every automotive is becoming kind of this kind of a move towards for EV segment. So talking about prototyping, which your question asking, so every customers are kind of an automotive segment. The first and foremost activity is prototyping. So any kind of a design sketch level, even from the engineering or their kind of part manufacturing, without prototyping, you cannot take it to the next level to take it kind of a decision. Either you want to do kind of a part function or testing, or you want to do a fitment or design validation. So that is why status is right now in a very inflection point. We are taking this to a very next step, not only limited for prototyping, in the advanced level of prototyping also, where people directly can do their kind of a design validation and testing. So because we have kind of certified materials which comes directly can use frequent to kind of traditional materials, whatever comes to the strength, we can able to use into that one. That is where you can make a key difference how this part can able to do performance in the field. Some of them classified for 200 to 300 degrees Celsius. Some of them we have an excellent impact resistance. And like Mr. Laditji mentioning, so some of those lighting parts also is one of the major requirements, because our customers in Audi, like they want to take kind of a prototyping. They mentioned that their key customers take their kind of an cars price primarily based upon their kind of a design factor. So lighting comes a very major role. So that means a lot of prototyping you need to do a lot. And this prototyping you will see one is on aspect of that aesthetics, another one is on functional. So even we also actually been very much advanced in the way along with kind of an varrock team, because varrock team also pushes some of our limits. Actually, they want to do some more external test, which has been very really we also not think of that one. So they also do those kind of an almost some 150 to 200 amount of test actually in the parts. And along with the part of learning, our R&D teams also expert in the way of their material. So that's some of the new development we are increasing in our product portfolio continuously. So new and new materials for new applications in the prototyping and also for the end applications we are doing into that one.
Thank you. Now, my question is to Mr. Ganesh Babu that I think we have heard from the panelists their challenges and how their experience on this. So, over to you, Mr. Ganesh Babu, just to understand, conceptual tooling and conceptual prototyping versus array 3D printed prototyping and tooling. On the parameters which we wanted to understand, the tooling cost or the prototyping cost, conservative versus 3D printed, and the tooling cost, yes, the strength, and the aesthetic. I think these are the three area where you want to understand your views and your experience with the customers.
Well, thank you. It's been an interesting point that you have come up with. While we talk about concept realization today, I would look upon concept realization using additive as a great tool. Reason being that first and foremost, you have the flexibility to realize your concepts in physical form, and your designs are not limited to one off. Reason being, you are either sharing your concept to external resources for services or for manufacturing through subtractive processes. Now, when you have the flexibility to own a printer and start printing, you have multiple concepts that could be, first of all, realized. And the best of the concepts get into the next level of product freezing, product design freezing, or taking it to the next level of manufacturing. So, ideally, you begin with a concept to give you an enhanced product that could be well accepted by your end customers or the larger customer users that could get the benefit with. And more importantly, the organization that comes up with the best design always is up on the ladder for having to be creative. So concept is well addressed with additive manufacturing. However, concept shouldn't have a certain limitation. While we talk about concept realization, if we are going to look at making concept with a single material, and if you're getting challenged to the next level of post processing to realize the end realization of a given product, then you get into various stages of skill sets that you're dependent on for post processing. But here again, Stratasys provides you the solution to work with high fidelity modeling to realize your end realisms as a single print outcome. So, which is truly beneficial. This is the true evolvement of the technology from a raw concept, which is single stage. Today, you can realize and realize parts that are more core to a designer's perspective, a product manufacturer's perspective. So, concept is no more merely, while we talk about prototyping is not for visualization alone. It is furthermore, even if you're looking at an FMCG product today, having the marketing team to look upon your first sample that gets rolled out from a 3D printer, all in a matter of overnight printing or in a day's time, gives various inputs in terms about how this product could be presented to the market when it has to be set for production, or what could be an ideal design that could be chosen. So quite a lot of questions answered at the concept stage itself today, with the flexibility to pick and choose the right technology for realizing concepts. Ideally, if you're limited to working with a single concept, single material, and going along with a single concept, you have limited choice to select and start working. And more importantly, the creativity in a designer is getting hindered. So there's quite a lot of value add by looking at additive manufacturing, if that's the take on concept. But when you're looking at manufacturing, well, there is definitely not going to be a solution using additive for meeting all those multiples of huge production quantities that you're looking at, whether it's polymers or sheet metal parts or castings and so on and so forth. But can you think about bridging that gap for the time spent in our manufacturing tooling, those multiples of weeks and months that you spend, the huge amounts of investments that you make, can it be narrowed and shortened down for meeting a certain set of batch quantities? Reason, a given product has to get an approval with the end used material. However, with the limitations in 3D printing, if that is a big challenge, you have the flexibility to even print a polymer mold to do printed injection molds, or you have a polymer tool that can give shape to metal. Now, I talked about the Origin P3 technology, which can also get you a very fine finished core and cavity that could be printed, and the tooling applications wherein you can inject polymers into a polymer tool to get those initial batch quantities, wherein those could be well addressed for testings, evaluations by the authorities before the product can get an approval, can all be done out. And more importantly, this also serves the aspect of the complications in tool manufacturing. It can also give you a realization in terms about the adaptability of a given design and its functionality when you're trying to try out those first few sample parts. So it's a great takeaway in terms about productionizing. Well, before stepping into productionizing, bridge to production using Stratasys tooling is a great application that needs to be actually more and more awareness needs to be brought into the market, where people need to get to realize that 3D printing is no more just a ball game for getting a concept realized in physical form for visualization, but it is beyond that. Today we talk about beyond prototyping in every given sphere of 3D printing or additive manufacturing. And that is where Stratus stands by with all these multiple technologies. The right selection of technology and the material can really give you the requisite quantities that are batch quantities. But the latest technology, the P3 technology, here we are talking about a technology for small, critical, complex geometries. You would be able to produce those few thousands of parts. These few thousands of parts, maybe one of the machines cannot meet those requirements, but it's truly a fast technology that could enable you to quickly have those initial quantities and numbers addressed. A few tens of thousands also can be achieved on the smaller geometries, limiting your tool manufacturing, limiting investments on tooling, so on and so forth. So ideally, the best choice of selection is what could be the right material that could equate your performance-based applications. Can a 3D printed part really come closer in terms of addressing those functional checks that you need to carry out? And all these pointers can be well addressed by selecting the right technology and the right materials. And then a little bit of thought goes in, because additive is a very simplified process. It doesn't call for too much of skill sets to man these machines. However, with a little bit of thought process going in for selecting the right orientation during the print process can give you wonderful results equating to injection molded quality, addressing finer accuracies and tighter tolerances on the outcomes that have been printed and produced.
Thank you, Mr. Ganesh. I think that's quite. I think that's. Completely agree with you. In fact, even when we deal with the customers, especially in EV, whether it is two wheeler, three wheeler, four wheeler, LCV, commercial vehicle, so people normally ask for, can we see the product? So I think your solution actually answered that questions very well. And we also, had a lot of challenges on faster delivery of prototype, especially with tooling. It used to have take around 4 or 5 months, which I think with the 3D printed prototype, it has helped us a lot as well. Over to Mr. Pritesh Doshi. Mr. Pritesh, if you can explain your experience. And also, I want to understand beyond prototyping, what's your view on the mass production? Uh, is it possible in future that 3D printing, additive 3D printing can help us for mass production as well? Over to you.
Yep. So first of all, thank you, Subrata, for the introduction, and also thank you to Mr. Ganesh Babu for presentation and then walking us through the technology that they bring to the platform. Yeah, means at this point, if I talk more from the perspective what we do here at Dana, so we are more of a powertrain company. So most of our components that carry the torque from the source to the wheel, and that's where you need to make sure that your parts are capable of carrying that stress and then are durable. So when we talk about 3D printing, we are actually looking at this at this point as an advanced development and exploring different options how we can replace the conventional ways of producing the parts and then bringing the 3D printing into the technology. So we are very actively using it in prototyping. When we look into bringing this into series production, the major challenge that we face is we need to always test our parts from off the tool. So when we take our parts for validation testing, we need to make sure that the parts are off tool. So if we take a part from 3D printing and we do the testing on the prototype with a 3D printed part, then that would not be something which we can validate and use it like this is a part which is tested for durability, life, or any other drive cycles. We use majorly this 3D printing at this point to see how the part will look and feel and how the two parts will meet. But of course, yes, what we see more and more like when we print these 3D printed parts and use into our powertrain technology, majorly for conventional or even electric domain, uh, the amount of time that we invest into CAD design and then FEA analysis, we are looking into options like how we can even minimize that and directly print a prototype part and use it for some of the validation. That's what we are also experimenting. And one of the major challenges that we face right now is availability of material data sheet there for 3D printing and some of the standards that need to come. So in conventional material and conventional productions, you have the standards well written, and that's where we are also looking at that industries where more open and transparently sharing the information with each other and more from the 3D printing technology providers and also the organizations which are trying this and exploring these options that they bring this at one forum and then we can fast track this experiments. That is one of the important thing that we are also doing within Dana across different locations. Uh, how we can adopt this 3D printing for parts which are actually involved into the power and torque transmission, majorly of torque and speed transmission. What we are also looking at is when we are going into some low volume production, that's where we are also exploring how we can look at parts which are like casings or some of the parts which are not actually required to do go through the durability analysis, that we try those parts or some of the plastic materials where we want to try it out in the early stage and then bring it to the mass production through the 3D printing part itself, where we see the feasibility and even the benefits in terms of cost and time. That's what we are approaching. Another important part what we are looking at is our designers when they design the parts. It's when it is 3D printed, we need to probably look at also newer and different approaches than we design a part for conventional printing, and that's what we are also building a database in house that. This can further utilized and then we are creating some standards and documentation which then uses for our further adoption of this technology into our mass production. So that's where we are right now. We also see that one is, and that's what I learned today also from Mr. Ganesh Babu's presentation, that there is always an option and possibility that you can blend multiple materials in 3D printing. That's what we have seen majorly from the materials which are maybe from the plastic and metal that you can blend. But what we are also looking for is option when you are producing electromechanical parts, then how we can blend these different electromechanical parts when you are manufacturing some, say, capacitor or condenser and other parts, how we can make those parts through 3D printing. And that's what we are also working with some of our partners in the area of 3D printing.
That's quite interesting, actually. Always, it's nice to hear the practical experience and the case studies you already had. My Mr. Lalit Ahuja, my question is to you. So I think you are already getting a lot of benefit out of additive 3D printing. So what's the next step? What's the future of additive 3D printing as per you? And in Varrock also, like what are the support you're going to get from additive 3D printing in future? What's your expectation?
Okay, is a next era of manufacturing is we can say is adaptive manufacturing. Okay, because in reducing your time efforts, okay, and lot of challenges what the designers is facing into modifying their CAD or design because of the manufacturing capability is not there or is not manufacturable. A lot of challenges are there in the design side with respect to the manufacturing. But with that adaptive manufacturing, yes, we can reduce this all challenges, which is actually is very very important from the design perspective, and we can reduce time or efforts of the designer and even the manufacturing team. Okay, because they always come with that problem. Okay, in front of the designer, and we as the other side of the design, like one of our colleague who is, I think is already left. So he was explaining how he is making the car, okay, and what type of testing and validation is doing. It's not everywhere the same thing, but normally questions comes on that product quality, not by the plant or by that customer. Is always focusing is the poor design. So there is a good part with this technology. We can reduce that the efforts as well as like testing time, what exactly we were really facing a lot, and more on that efficiency, what exactly we want as a product to be performed as a reliability point of view, or a capability or the cost effectiveness point of view. This is right now the challenge in front of us because it's a competitive world, and for the EV market specifically, a lot of newcomers are there in the market. Okay, they are looking off the shelf concept, which may not be possible for to adopt or to use as it is, and they want some quick solution without any cost. So this adaptive can help them or help us as well to give the solution where we can reduce the efforts and cost for the development. Mhm. And give that customized design to them, especially for that outside manufacturing or aesthetic point of view. So, so the role of adopt 3D printing is really, really is very, very important, and the future is very broad, very, very broad. Frankly speaking, now when we have seen that adaptive manufacturing or like the 3D solution, it was SLS, move to SLA, then FDM, then like P3 technology, even like EBM technology, DLP technology. So many technologies are involved. Now even metallic comes in the picture. Okay, there's no need for that. In fact, we tried as well for that, for the casting part, which is really very challenging in India specifically. But if we produce that parts through the printing, metal printing, so efforts is very very मतलब is efforts is reduced too much, and we are able to fine tune and where the specifically the volume of the product is very less. Very less means like hardly 100 or 2,000 numbers per month for us, for customer who want to use those technology and don't want to invest. So I think if you use as it is this type of concept or technology or product on their particular vehicle, so it will reduce their efforts, our efforts, as well as give the benefit to the end user. Okay, with that low cost. Okay, so I think future is good, and we should focus on that, and others as well to focus to adopt this product or technology, especially material. Of course, this is not material in adaptive is not so wide range, but still uh, manufacturers are working whosoever in this technology, and we have given the challenge what exactly we are looking, and as a specifically uh, they should work on their standards material, the way that polymers are available with the different range, different categories. So same thing, they have to come with that so that it's easy to us to adopt those standard material. Okay, which help them to reduce their cost, which will also help us to reduce the our manufacturing cost. Ultimately cost benefit goes to that end user. So I think is really a good future for that if really we work all of team members on this direction.
Yeah, that's I totally agree with you because yeah, I think this time reduction as well as maybe for future, as you mentioned, I think few more panelists also mentioned of for small batch production. I think that beyond prototyping also that can be we can grow because there are a lot of small batch production happen in every almost every industry, and
Yeah,
maybe sometimes the tooling for making those small batch of production parts are difficult considering the cost and the time. So if you include the total tooling cost, that will be I think too costly as well as too time consuming. And so for kind of small batch production, I think that can help us a lot. Mr. Satish Kumar, I just want to understand your view on the so what are the as per you what's the next steps towards future for additive 3D printing, and what are the limiting barriers for manufacturing adoption?
Okay, so one is actually what's next. So what's next primarily from industry perspective, materials actually, because everyone comparing with respect to the traditional material. So that is the reason even Status is also actually putting a lot of efforts in with actually in collaboration with many industries like Sabe, Saf, Henkel, and also we have been acquired a company called Covestro recently in additive business, and we have been extending the business of additive throughout for kind of an every area for the kind of an adoption for throughout for the production requirement. So material is one of the most important in the next phase of the development everything. So strategy is also focusing in the direction everywhere, and we are also doing a lot of efforts and also bringing up some of the custom material like specific focus for EV related. We have FST, flame, smoke, and because everywhere you can see some news, some vehicle is burning, some of them catching fire. We specifically have an flame, smoke, and toxic resistance material. Like that, we have been increasing in the bandwidth more about it, and we're also having a specialist material called ESD, electrostatic dissipative material, for a specific application on semiconductors, everything into that one. So scope is we are increasing a more in the kind of a material for increasing the applications. Your second question, can you repeat that second question you mentioned?
Yeah. So, what are the limiting barriers for manufacturing adoption?
Okay, so primarily in India, everyone is having kind of a lot of information about additive. So I would say awareness is there, a lot of things, but understanding of 3D printing still a lot of things we need to be there, because that is the reason some of them people understand there is a failure happening in their 3D printing industry, because right application with the right material is what we call as a success. So those things you can able to get it from the industry leader like Stratasys. So you can also reach out through Design Tech team. So what kind of an application is your major challenges? We can help you, because we have been an industry leader from all the automotives. We can name it from Tesla to all the level of industries in the segment. We have been serving with that one. So we know the challenges, we know the solutions.
Thank you. So I think just to summarize the points, like this this material blending has helped us a lot for this adopting this additive 3D printing, as well as the reduction in time, and as well as the cost has also helped us to adopt the additive 3D printing. And I think over the years also there are a lot of opportunity that's for small batch production. Also, it will help us to get to the next level. And you never know with this technology disruption age what will happen. I request Mr. Ganesh Babu if you want to add anything. Otherwise, we'll go to the Q&A session after this. Mr. Ganesh Babu, anything you need to add?
Well, as you have very well summarized, I think the best thing is these are the platforms that is creating quite a lot of awareness, and more importantly, we need to make it quite often to engage with a larger set of audience and take forth how the technology advantages needs to be chosen and selected, and probably even from all the OEM side, they need to take the onus and responsibility in arranging platforms for evangelizing additive manufacturing to every core segment of any given vertical for that matter. And EV is something which is on the top today. And we need to also go forward to talk in terms about what are the limiting factors. Now, when I look upon any limiting factor apart from the materials, or apart from there are also size factors that come into the picture. What are the limitations in terms of size, and what is the time factor in realizing parts that could be used as end use parts of the automotives, EV vehicles, etc. If we are looking at beyond a certain segment of meeting requirements, how could we also enable faster throughputs without having to compromise on its functionality is a core area that the OEMs need to look upon to speeding up the process, and the fact of cost that comes into the picture. Today, it has been a technology which is very, very affordable. Additive has become a more affordable technology, but there has been a couple of decades ago when industries had the fear of investing very hugely on adapting additive technologies. That has also been a limiting factor. But we have to bring forth and let the industry segment know that additive is more affordable today. And also, I would request upon the various OEMs, wherever from every given platform, to really focus on cutting down on the cost of consumables, which is primarily the cause of concern that is hurting people to adapt additive as a technology. And from the user front, if I have to put myself, these could be some of the pointers that are probably stopping or not a welcome point of view in terms of adapting additive as a technology. Otherwise, when it comes to realizing the true potential of additive is very largely known to a larger segment of industry verticals, and this has to be carried forward. And many such platforms has to come up to address the needs of industry verticals, specific to industry verticals, and the message needs to be carried forward.
Okay, thank you. So, Sakshi, there are a lot of questions on the chats as well. I can see. So,
Yes, sir. I'll just show the questions one by one, and you can read out the questions, and everybody, members in the panel, can answer them.
I'll just select some of the questions and I'll
Yes,
ask
sure. Sure,
from
sir.
the chats. So first question is a specific question for Stratasys. Do you provide 3D printing solution for semiconductor chip equipment companies like AMAT, ASML?
So for semiconductor industry, actually most of our semiconductor industries are our customers, actually, including in India, Intel, like major players like that one. But directly semiconductor printing is not possible in our technology. But associated to that kind of a printing, we can able to support a lot to that.
Uh, the second question says, are the three, I think already we have discussed this point. Are the 3D printed parts are still being used only as prototypes towards concept development in EV model vehicles? If not, what types of parts in EV currently being used at end user vehicles? Already we have discussed this point. I'll go to the next questions by Mr. Anil Kulkarni. Accuracy is one of the issue. We observe that spline accuracy, internal threads are not get achieved with AM. Is there any solution for it?
Maybe I can answer for that one. So primarily in any plastic parts are generally the 3D printing, that directly printing a threading is not recommended first of all. So there are some DFAM principles are there, and we have also have some application guide in our statuses page. You can also refer on that one. So how we can achieve best in that one.
So, is there any? My doubt was, is there any accuracy difference between 3D printed parts and like real parts? Like, how much is the difference and all? Satish, if you can answer.
Okay. So this is very generic, but accuracy depends on many parameters, like how are you orienting the part, what are the consideration you're taking for the materials, everything into that one. But if I consider like our P3 kind of a technology, which is we primarily focused for production, the accuracy is very good. Like I would say, actually, some of them even coming close to 50 microns range, you will get into that one. So these all depends on materials orientation, and you should also understand the part requirement. So everything plays a role in getting that accuracy for you.
Even I think this material selection in additive is one of the major criteria to get that also.
That is a
Next
very
question.
important criteria.
Next question is to Mr. Lalit. Good evening, Mr. Lalit. Has Varrock started using 3D printed parts in production or on-road vehicles, or is it still a concept or feasibility basis?
Okay, so I've already replied to that guy separately on the chat box. But anyway, I can reply here as well. We have not yet started for the production. Though, as I mentioned in my one of the conversation and explained, we are planning to start working on the production on based on the tool, because adaptive we cannot use as it is as of now for the production because of scalability. Okay, because some of the parts are too big and there are limitation on the machine as well, so we can't join for the production point of view. For assembly or concept proving for the feasibility check, yes we can, and that's what we are doing as of now.
Next question is, do you think AIM will ever be able to produce large structures? I think we have already discussed, but anyone wants to answer can answer, or we'll go to the next question. Okay, so the next question is, as this is a layer by layer process and may not sustain for torque and heavy load application, is there any solution to overcome it?
FDA with the solution, I believe Ganesh and is the right person who can. It's not an issue because such a high load we can that material can take, right? And even the
Well,
vibration, even we tried vibration testing as well for this fixture.
Yeah, I think we had a lot of discussion in this. I think Mr. Ganesh Babu will agree that additive manufacture 3D printing is one of has an upper hand towards other process on this strength point. I'll go to the next point. We are talking about serial production. How can we overcome strength issues? Already we have discussed now. Uh, uh, okay.
I can answer for this one. Maybe
Yes,
for the
yes,
serial
please, please.
production. See,
Yes.
we recently have many case studies actually we published in our website also, very focused for because right now everybody is looking for how we can able to make parts for 500,000, less than 2,000, 5,000 into that one. So this is the reason we introduced our SAF and P3 technology specifically for that one, where you will get kind of a very high impact load also. And we also have coming up with completely an open material license on that one. So even there are things you can able to identify your own material, you can fine tune with our printer, that also can be worked on that one. So this is completely a game changing innovation in that segment.
I don't know whether it is a statement or a question. Good structure for heat transfer application. Good material to absorb heat 3D printing. How much thickness, volume to cool object. Best software to design. I think I think point number four is best software to design. Anything need to add, Mr. Ganesh? You need to add anything?
Yes, I would like to take this question. First of all, while we talk about good heat transfer, it very best applies to the customized processing in additive manufacturing. Today, while we talk about good material to absorb heat in 3D printing, while talking about polymers, there is no polymer that could absorb heat. But how could you transfer heat from a given print surface all the way down to the build platform is in question. So ideally, while we talk about using high performance grades of material, we have the various grades of Ultems and high performance materials in the FDM technology from Stratasys. Ideally, the best fit is to have an internal selective sparse structure by which, if the structure thickness, if the geometry calls for a too solid structure to be printed, during processing you have selective selection of applying a sparse mode or a customized internal fill, which ideally takes care in the polymer printing process that you'll have quality outputs without warpage during printing. And as a proven technology, Stratasys supports best softwares to work with. I could name Insight as a customized software for customized printing using high performance material, and it's an ideal fit. We also have GrabCAD Print along with Insight. These are great tools to work with. That exactly makes Stratasys as a leading technology worldwide when it comes for complex geometries, thin wall, thick wall structure printing using high performance materials.
I'll go to the next question. Is any topology optimization need before printing?
Well, topology optimization is something that it is generally applied to lightweighting of your parts, and more importantly, based upon your analysis from the geometry. Ideally, it's the best fit if you can optimize your structures without compromising the performance of a given geometry. It is ideal to optimize and start printing and check the various parameters of load bearing and performance of a given geometry. But predominantly, it is the material selection, and FDM, the production series technology today allows you to work with 16 different materials. So there are wide variety of materials that could be selectively chosen, and with the topology optimized structures that could be printed, tried, and tested.
Now I'll go to the first question. On an average, what percent of production cycle time can be saved while making an EV two-wheeler by adaptive additive manufacturing to the highest extent possible?
Well, it is a gross question in terms about what could be the production cycle time savings for making a complete EV two wheeler. So there are platforms that could print parts of nearly 1000 millimeters with the Stratasys FDM technology, and coupling it with the Origin P3 for more performance based, smaller outputs, higher throughputs, as well as good surface finish, tighter tolerances. It's a mix and match. What could be an ideal technology that you're choosing? Are you looking at the exterior of an automotive completely printable with FDM? It's a great choice. But when it comes to the internal components, there the selection with Origin or the polyjet technology also plays a role. So all summing up together with multiple technologies from Stratasys, if you're looking at printing a two-wheeler, a week's time should be comparable time in order to realize the complete hardware part of printing with multiple techniques, technologies from Stratasys to support, and that could be a possibility.
Two more questions added in the meantime. What is the scope on metallic 3D printing? Anybody want to answer on this? What is the scope of metallic 3D printing?
Whether it is metal 3D printing or metallic 3D printing, okay, let me take it as a metal 3D printing process. Today, while we talk about metal 3D printing, the EV vehicle in general has minimized structures, minimized components. While we talk about an EV automotive, ideally we are looking at minimalizing the total component or the bill of material on the component list for an automotive. So metals are very, very nominal because you don't have a combustion engine which calls for a metal part to be printed. However, wherever there is a necessity to print, ideally, today look upon Stratasys FDM as a technology. We have materials such as PEC, Antero, or Altum based materials. These are all game changers. Today, aerospace and automotive industries have replaced metal parts with 3D printed plastics using the Stratasys FDM technology.
Another
I'm
question.
just adding. I'll
Uh,
just add to that previous question. So in the part of metallic 3D printing, you can still use the regular or FDM technology. Like you can also go for like investment casting and sand casting and many other process also you can achieve with that one. So that is how you can able to make it very cost effective because it's not only producing part. How cost effective are you producing also matter. So you can able to make in such a way like that for your production also with cost effective you can do that.
Uh, this is the second time Mr. Sujan has asked this question. I'll ask the last question. Mr. Sujan Kumar Shetty, Jan University. With additive manufacturing, the cost of entry is still prohibited to many organizations. How it can be overcome?
I will answer for this one. See, there are varieties of material available. So, what is your selection of material? So, you need to select from material aspect on that one, because material is the one it is determining your application and also your cost factor. So, that is what you need to start from there. And right now, we have wide ranges of materials available. We have standard, engineering, and high performance. So every time it is not your requirement to go for high performance. You can also start most of the application with engineering and standard material. And like I mentioned, right now we are also coming with completely an open source material ecosystem also. So if you find your material is much cost effective and it can work for the kind of an requirements, you can still make it very cost effective approach on that way.
So I'll just take the last question, almost similar last two questions. I'll take the second last one. Does adoption of 3D printing in EV manufacturing increase an EV makers' dependency on China for supply chain as far as 3D printing materials are concerned? So on the supply chain of the 3D printed materials, I think do we have a more dependency on China for 3D printed materials?
Well,
Maybe.
if I may, I have to take this question. I would like to summarize that today Stratasys as a platform offers you materials from Stratasys itself, except for some of the technologies that allow open source materials. So there is no player in China that is supporting to work with predominantly the major players in additive. So ideally, we are looking at an OEM supported material that controls and that also results in quality outputs. So adoption of 3D printing in EV manufacturing definitely has been there from pioneers like Reva Engineering, which has been acquired by Mahindra Electric now. They're all have been users. Under the hood, component manufacturing using FDM technology has been followed and practiced. So when it comes to the materials, there is no Stratasys technology that depends on China for any material supply.
That's quite interesting, actually. So I think it's quite similar to Mr. Ganesh. I think the raw material part, nothing there is a more dependency on the China or something. It is like a normal
I
material because it
I
depends on
just
the
want to add one point along
yeah.
with that material selection. So one of the material actually we are using for a PA11 actually. So that is completely made from castor oil. And might be that slide was even Ganesh was mentioning actually in his slide. So that 80% of castor oil things goes from India only, by the way, to the news to the audience.
Thanks all the panelists, Mr. Rahul Shonak, Mr. Lalit Ahuja, Mr. Ganesh Babu, Mr. Satish Kumar, and Mr. Pritesh Goshi for the wonderful discussion. I think definitely the team as well, the panelists as well as the attendee will get benefit from Additive 3 Thank you. Over to you, Shashi.
Thank you so much. We would like to extend our gratitude to all the esteemed panelists for the exhilarating session and for a very special thanks to you, Mr. Ghosh, for superbly moderating the session. We would also like to thank everyone for investing their valuable time and supporting the event. Hope that the key takeaways from the session were instrumental in paving the way for sustainability. We promise to be back with more exciting sessions. It's time to say thank you again, goodbye, and have a wonderful weekend.
Thank you. Bye.
Thank you all. Thank you all, gentlemen. Thanks.
Good day. Thank you, everyone.
Thanks, Sakshi. Bye bye.